All right, welcome back everybody. Today we're going to get going with Chapter 4, and Chapter 4 kind of contains a mixed bag of some different things we're going to do with triangles. Okay, so a lot of different topics covered here. They're all kind of work together. You'll see how that works as we go through it. Okay, but in 4.1 we're going to talk about congruent figures. Objective I'm going to say is to recognize congruent figures and their corresponding parts. Let's get going with that right now. So first off, what do we mean when we say congruent figures? Okay, well, one way to think about it would be thinking about filling in the last few pieces of a puzzle. Okay, we want to match each of the pieces, okay, with the hole of the same shape. We could say that the hole that the puzzle goes in and the actual piece are congruent to each other. Now, we've already talked about congruent angles and congruent segments. Okay, congruent figures basically work the same way. I wouldn't say that piece 2 and space B are the same thing. They're not in the same position. They're not facing the same direction. Okay, but basically I can think about spinning them around, reflecting them maybe, and lying one on top of the other. Okay, and the way that works then, the way for these figures to actually be congruent is they have to have the same size, the same shape, essentially same angles, same curves on them. Okay, so that's what I mean when we say congruent, not the same shape, but basically the same size. They'll fit on top of each other. So our formal definition then of congruent polygons is we'll say polygons with congruent corresponding parts. Okay, they're matching sides and angles. So if two polygons are congruent, all their corresponding sides or matching sides will be congruent, as well as all their corresponding or matching angles. So for example, I have a pair of congruent polygons here, and basically they are congruent. I can tell that because they'll sit on top of each other, they match up. And what that means then is that all their corresponding parts, which I have in matching colors, their sides and angles, will be the same as each other. Okay, my two blue segments looks like they'll be congruent. Same thing with the red, same thing with the green, same thing with the purple. Okay, each of these angles match. Okay, all my corresponding parts match. All right, that's how we know that they're congruent. All right, so let's practice working with this idea of congruence. Problem 1 says, if polygon HIJK is congruent to polygon LMNO. Okay, the way we'll name polygons is we'll just list out all their vertices or all their angles. So HIJK is just talking about this polygon on the left. LMNO is on the right. Okay, this question is asking, what are the congruent corresponding parts? In other words, list out all the congruent sides and all the congruent angles. So this one's a great kind of spatial awareness, spatial practice question. We need to figure out kind of how these two congruent shapes, which have different orientations and different reflections happening, match up with each other. So for example, it looks like segment KJ is congruent to segment ON. They're both kind of the shorter side on the top. So since it says these are congruent, these polygons are congruent, I know that segment KJ is congruent to segment ON. All right, because with congruent polygons, all corresponding parts are congruent. That's one set of sides. Let's do the rest of the sets of sides. Looks like we also have that KH is congruent to OL. All right, looks like we also have HI is congruent to LM. And then that means the last set of sides also is going to have to be congruent. We have JI is congruent to NM. All right, so when I say these two polygons or these quadrilaterals, four-sided shapes are congruent, that means all four sets of corresponding sides are congruent. And it also means all the corresponding angles are congruent. So for example, if we look at angle K, it looks like it corresponds with angle O. So that means that angle K is congruent to angle O. And we do that with the rest of the angles as well. Looks like H and L will correspond. So we can say angle H is congruent to angle L. It looks like I and M will correspond as well. Oops, we'll mix it up some different colors here. So angle I is congruent to angle M. And then finally, that means the last set of side angles have to be congruent as well. We have angle J is congruent to angle N. All right, so by saying that two figures are congruent, we're giving you all this information at once. All their corresponding sides and all their corresponding angles will be congruent to each other. Now, there is one trick with this question. I actually don't even need to use this picture to come up with this information. Okay, notice, for example, that we said segment HI is congruent to segment LM. Okay, notice in my congruent statement, HI is the first two letters on the first polygon, and LM is the first two letters on the second. Okay, so they're in corresponding positions in that name, in that congruent statement. Same idea, for example, if I look at my congruent statement, K and O are both the last letters. I'm thinking I could find K and O congruent down here. Yes, I can. Okay, so a properly written congruent statement has corresponding parts, the angles and sides, in the right order. So there's actually a lot of information we get from this congruent statement. Also, with that said, when it comes time to write our own congruent statements, we need to make sure that we are matching those corresponding parts in order, okay, to get them written correctly. All right, so in problem 2, let's put this idea of congruence to work and actually do some solving with it. Part A says triangle LMN is congruent to triangle PQR. Okay, once again, this simple statement tells us that all the corresponding angles and sides of these two triangles are congruent. We want to know what is the value of x. Okay, now it looks like there's some algebraic expressions for each of the sides or most of the sides of these triangles. So what we can do then is we can set up an equation to solve for x. And the trick is going to be matching the correct sides together to make that equation. Now to do that, I'm going to say it looks like side LN is congruent or corresponding with side RP. Okay, it looks like these are congruent corresponding sides. Now I can check that with my congruent statement. Notice that L is the first letter, N is the second. Here's my LN. Okay, and in the second statement for PR, P is the first letter, R is the second. So I know based on that for sure these two sides correspond. So the equation I can set up then is I can just set their side lengths equal to each other. I can say that 10 is equal to 2x plus 4. All right, and once I get that equation, I can solve it. Now notice I didn't do anything with the 12 in this problem. I'm going to say I can't do anything with it because I don't know what the length of this corresponding side is. Same idea with the x here. I can't do anything with it because I don't know what the length of its corresponding side is. Okay, I have to use the sides that actually match up and allow me to fill in an equation. So once we have that equation, we can solve for x. I'm going to subtract 4 from both sides, which will give me a 6 is equal to 2x. And then I'll divide both sides by 2. And we'll end up with x equals 3. Okay, so there's how we can use congruent figures to do some solving for side lengths, or we can do angles, which we'll see in the next one. Okay, problem B is pretty similar. Why don't you take a minute, pause the video, work through part B in the note guide, and then you can hit play to get an explanation and check your answer. Let's go ahead and run through part B. Once again, we've got triangle ABC is congruent to triangle KLM, so we have congruent triangles. This time we want to find the values of x and A. And it looks like A deals with side lengths and x deals with angles, which is a little different from what we just did, but we'll kind of approach it the same way. Let's start off solving for the A. What I need to do here is match up a set of corresponding sides that I have expressions for both of them. And I'm going to say the way to do that here is I'm going to match up segment AC with segment KM. And we know these sides are corresponding because they're both the hypotenuses of these two right triangles. Remember, right angle points to the hypotenuse. in both cases. And again, if I wasn't sure, I could always check the congruent statement to make sure my letters match up. So we have congruent corresponding sides, so we can set their expressions equal to each other. We can say that 2a plus 30 is equal to 4a minus 4. And again, I ignore the 2a because I don't know the measure of its corresponding side. Same thing with the a plus 1. I don't know its corresponding side. I have to use the sides that are corresponding, the sides that match up. Okay, let's solve that equation for a then. I'm going to subtract 2a from both sides to get the a by itself. That's going to leave us with a 30 is equal to 2a minus 4. Then we'll add 4 to both sides to give us 34 is equal to 2a. And then I'll divide both sides by 2 as we run out of room here to end up with our a is equal to 17. All right, let's solve for the x now. Now the x deals with an angle of the triangle, and I have corresponding parts. I know that c and m correspond there, therefore they have to be congruent. Now the issue is I don't know angle c right off the bat. What I can do is I can solve for it, just like we did in the last chapter. I know the triangles always add to 180, and I know the two other angles of this triangle on the left, 45 and 90. So if I take 180 and subtract 90 and subtract 45, what we'll end up with here is 45 degrees for this angle C. All right, once I know that angle, I can say that angle C is equal to angle M. In other words, 45 is equal to 3x. And then we can just divide both sides of that equation by 3 to end up with x equals 15. Okay, so there's an example how we can use congruent corresponding parts to set up equations to solve for both side lengths as well as angles. Two more things we're going to talk about quick, and one of them is another theorem that will show up a bunch in this chapter. We're going to call it the third angle theorem, and it says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent as well. So for example, if I have these two triangles here, and A is congruent to D, as well as B is congruent to E, so I have two triangles, two angles congruent, that means that the other angle, C and F, have to be congruent as well. The reason for that is the proof wouldn't be very hard since both these triangles add up to 180. If I subtracted the same amount for A and D from 180 and the same amount of E and B from 180, I'd get the same answer, the same C and F. So we're going to put that theorem to use in 1 minute here. But problem 3 says, are the triangles congruent? Justify your answer. So we've talked about what congruence means. We've used it to solve for side lengths and angles. The last thing we're going to do here is determine whether or not we actually are looking at congruent figures. Okay, now come homework time, this will basically be just a yes or no question. But here we're going to do a little more and kind of justify our steps as we go just to make sure that yes or no makes sense. So if I want to show these two triangles are congruent to each other, what I need to do is I need to show that all their corresponding sides and all their corresponding angles are congruent. So let's start listing that off. I can tell right away that AB is congruent to ED. Okay, because they're both marked congruent with a single tick mark through them. Same thing, I can say that BC is congruent to DC because they both have a length of 4. And then also I can tell right away that AC is congruent to EC because they both have a length of 6. All right, we can tell all that just by looking at the picture. Okay, we'll list them out just because for this problem. We want to show kind of how all 6 parts go together. And as far as a reason for each of these go, They're given to us in the picture, so I'm just going to say this is given information, nothing to solve for yet. All right, now as far as angles go, there will be some solving. Right off the bat, though, I'm given that angle A is congruent to angle E. They both have a single arch through them, so we know they're congruent. And again, we'll say that's given information. And then we get into the actual solving and justifying. Now notice in the middle where these two triangles come together, I have a set of vertical angles. Okay, we know vertical angles are always congruent, so I can say that angle ACB is congruent to angle ECD. And the reason for that, again, is there's vertical angles, so I'm just going to say vertical. It's kind of my justification for that. All right, so the last thing we need to do is show that angle B and angle D are congruent to each other. Now, we already have two triangles with two sets of angles congruent. Okay, therefore, by the third angle theorem we gave you a minute ago, I know that the third angles also have to be congruent. So I can finish this off by saying angle B is congruent to angle D, and my reasoning for that would be the third angle theorem. All right, so what we just showed, what we just justified, is that between these two triangles, all three corresponding sides are congruent, and all three corresponding angles are congruent. Therefore, to answer the question, are the triangles congruent, we can say yes. And it doesn't ask for a congruent statement. We'll give it anyways. Let's say triangle, and I can pick any order I want for the first triangle. We'll say triangle ABC is congruent to triangle. Now, I do need to stay in the same order. A corresponds with E on the second triangle, so we've got to put E first for the way we name it. And then we go to B next on the first triangle. B corresponds with D, so we'll say ED. And then both triangles meet up at C. So we can say, yes, triangle ABC is congruent to triangle EDC. All right, there you go. That's our section on congruent figures. We will build off that for the rest of the chapter, so make sure you understand that. Start working on the homework, start cranking out some math problems, and like usual, if you need some help, we'll be here to take care of you.